Okay, so let's get started. In this training module, we're going to be taking a look at how to dial in our mass airflow calibration curve. Our last tutorial, we talked about the basics, the fundamentals with the mass airflow, so we understand what it represents, why it's important in the engine control module programming for a Mustang. And then we talked about making some file changes and updates so that when we fire up our engine here for this tutorial, that we're going to have a good starting point. And one thing that I actually found in that last training module is I actually made a mistake. So I want to go and talk about that here in the beginning of this training module so that you don't potentially carry through the same mistake. So that's going to be specifically looking at our MAF calculator. I actually entered in the wrong stock diameters for both the aftermarket intake I was working with, which is a JLT cold air intake for a GT350, and for the stock GT350 Ford mass airflow diameter. So these two are actually incorrect, which caused the calculator to calculate the incorrect values to start off with for the tutorial for the actual MAF table. Very important that that is accurate. So let's go and talk about that real quick, and then we'll talk about a couple of the changes that we made, and then we will jump into the VCM scanner to also discuss a few things that are very important for getting successful results in doing the MAF tuning process. So if we jump over here to our Excel spreadsheet and we go in here to our MAF table, so this is our MAF calculator. If we go up here, we have our yellow values. So these are the values that we would change based on the stock diameter of the MAF housing and the aftermarket intake MAF diameter in the housing. So I actually measured this the best I could with just a ruler. What I measured was 3.625 inch as the diameter, the inside diameter of where the MAF sensor is located in a GT350 MAF housing. Now that equates to about a 92 millimeter. Ford advertises it's actually a 90 millimeter, so I'm ballpark close. Again, I'm doing this the best I can with just a basic ruler. The best way to do this would be to use an inside mic and actually mic the inside diameter of the MAF housing, but I don't have one here at the shop right now, so I don't have the capability to do this. So I'm eyeballing it. The most important thing here is that we're getting relatively close values. They don't have to be perfect because we are starting off with a rescaled MAF curve here in the blue. So we put the stock here in the yellow, we copy paste from the file in here, we calculate the blue, we copy this and paste it back into the file. We want something that's ballpark. We're going to do the fine tuning here. We want something that's going to get us maybe plus or minus 5-10% close, and then we can do that fine tuning for the rest to get the MAF curve dialed in. So the next thing here is going to be the JLT intake, which they advertise as 120 millimeter diameter. I was actually measuring it to be about 4.72 inch, which equates here to about 119.88 millimeter. So that's actually close to what they advertise. So I simply copied these values here in the blue and I pasted them in here to the table that we're finding right now. This is actually what we're gonna actually start to work with here in this training module, and we're gonna calibrate from this point. So it's just a starting point. Again, the calculator is gonna only be as good as what you put into it. It is going to do the proper calculations, but in my case, I'm close on the stock GT350 MAF housing, so I'm going to go with my measurement, not what Ford advertises, and we'll clean up, again, any of the deviations from that point. So this is getting us a better translation between our period value and to the, in this case, pound per minute or grams per second. Let's swap this back to grams per second. The calculator uses pound per minute. I like to reference grams per second, but so it's going to be giving us a better translation between the period and the grams per second airflow, air mass lookup within the MAF operation. The other few things that we've changed here are also things that are important to note and important to change, and we have those outlined and talked about here in the black, this little black box in the MAF calculator. Let's jump back in here. So we've turned off the cylinder air filter. This can be problematic in some vehicles. We'll see when we fire up this engine what it's going to do. If we're finding that the idle is unstable, a lot of swinging and oscillating in the idle, a lot of rough running, backfiring, then you're going to want to turn the filter on. This is right now the way we have it set with the filter off. It's turning off any filtering that's going on with the mass airflow. So you're getting the raw MAF sensor input from the sensor and no filtering that's done through the engine control module. Normally you want to apply filtering. It smooths out any of the registration or reading from the mass airflow sensor. I can tell you that the JLT intake is usually okay in terms of the turbulence going across the MAF sensor. I've done a couple of them with the filter disabled and they seem to be at least stable enough to use. We always want to turn this back on once we're done tuning the MAF, but this gives us a reasonable starting point. If you have an intake that is going to be turbulent across the MAF, and again, you have that backfiring, really unstable, idle, surging, stalling, you're going to have to turn it back on. There's no choice in order to do the tuning process. I have it off right now. Again, we're looking at the roll signal whenever we can. We also have MAF adaptation turned off. This was actually turned off in my file already. If it was enabled in your file, you want to disable it for tuning. And then if it was enabled originally, you want to turn it back on once you're done with the MAF tuning. So again, same thing with the filter. Then we also have our cylinder air anticipation disabled. This is a complex type of calculation that goes on. It's anticipating what's going on with that MAF signal. It's kind of like a learned step ahead type of thing. We want to generally turn this off again so it doesn't have that learned step ahead behavior for the MAF reading, for the air mass registration. Again, trying to get the MAF curve stripped down as raw as possible to do the tuning, the calibrating process. Then we turn back on the anticipation, then we turn back on our filter, and if the adaptation was initially turned on, we turn that back on, obviously to run it long term. We also went to the watt multiplier, max multiplier. We raised it up to 1.99, so these aren't going to do anything goofy when we're trying to calibrate the MAF curve. These are really needed to be raised if you're forced induction. If you're naturally aspirated, you probably could leave those values stock, but I've raised them up here just for proper tuning in working in the forward programming here. We've also went into the initialization switch for the desired air mass and for the idle switch here. We also set that to disable. This turns off any speed density influencing that happens within the Mustangs tuning the MAF curve. So we've prepped this pretty well. I've already went ahead and flashed the vehicle with the file. So when we fire it up, it'll be running on this particular file that we've made our changes from. I've actually renamed that file to a new name so we can see it's going to be stock plus JLT intake rescale start. So this is our starting point. And then we'll flash.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.